given you a question like this, 1 raised to the power of x is equal to 2, find x. Foremost, you need to ask, are you looking for real or complex roots or complex solutions? Because that is important question. Many times what people will do is they will start off by saying that let us consider 1 raised to the power of x is equal to 2 and let us take ln on both sides. Then we know that ln a raised to the power of b is equal to b times ln a. So this is going to be x times ln 1 is equal to ln 2. Then they will divide both sides by ln 1. And then cancel this and state that x is equal to ln 2 divided by ln 1. Now since ln 1 is equal to 0, this would mean x is equal to ln 2 divided by 0, which means undefined. So you are getting an undefined relationship. And the most important part or point you need to know is mathematically you cannot divide by ln 1. Why? Because ln 1 is equal to 0 and dividing by 0 is prohibited. Okay, prohibited, or you can use even a stronger word. The best word is cannot. Okay, you cannot. So attempting to solve a question like this in this fashion is blatantly incorrect. Now what is the alternative? The alternative is as follows. Now Euler has given us a formula. This is called as the Euler's formula. Now what is this? E raised to the power of I theta is equal to cos theta positive I times sin theta. Now if I take theta is equal to 0, then I get e raised to the power of I times 0 is equal to cos 0 positive I times sin of 0. This goes off. Cos 0 is 1. So e raised to the power of I times 0 is going to be e raised to the power of 0. And that is going to be 1. So left hand side is equal to right hand side. Now this pattern will repeat for all theta of the form 2 times k times pi, where k takes the value 0, 1, 2, etc. and so on. So that would mean to say, if I were to take e raised to the power of I times 2 times k times pi, that would produce me a value 1 whenever k takes the value 0, 1, 2, etc. So now I have a new relationship that connects 1 with an exponential value. That in turn would mean I can rewrite 1 raised to the power of x is equal to 2 as e raised to the power of I times 2 times k times pi, the whole raised to the power of x is equal to 2. So this is what I've got. Now what I wish to do is, let me move on to another page and show you the working. Okay, so this is what I've got. Now what I'm going to do is I'm going to be take ln both sides. So if you take ln both sides, what do you get? This is going to be ln of e raised to the power of, I'm going to write it as I times 2 times k times pi times x is equal to ln 2. Now ln of a raised to the power of b is going to be b times ln a. So this is going to be 2 times I times k times pi times x times ln e is equal to ln 2. But ln e value is equal to 1. So that would mean you have I times 2 times k times pi times x is equal to ln 2. I need x, so x is equal to ln 2 divided by I times 2 times k times pi. I cannot have I on the denominator, so I multiply by I in the numerator and divided by I. This is going to give me I times ln 2. I into I is I squared, so 2 times k times pi. But I squared is equal to negative 1, so this will give me I times ln 2 divided by negative 1 times 2 times k times pi, which is rewritten as I times ln 2 divided by, negative sign can be placed here, 2 times k times pi. So this is the value of x. So this is the solution, but it is not just a solution. This is a solution under the complex field. Okay, so not in the real area. Now in the complex spectrum, you can produce infinity number of solutions for this particular question. 1 raised to the power of x is equal to 2. But in the real world, not possible. In the real world, 1 raised to the power of x will never be equal to 2. So I just want to make that point clear here. Thank you everybody. Please like, share and subscribe.